Hi folks, and welcome back to Math with Captain Rod. Making this video here to help you out with your homework in section 6.6 in the college algebra Openstax text. We're going to look at 10, 16, and 24, starting with number 10. Okay, and the directions here are to solve for every one of these. Here solve for n, here solve for n, here solve for x. So let's take a look at this thing. Now you notice here this 64 is 8 times 8, and here we have an 8, and here we have a 2 to the 6th power is what that actually reads here. So there's a lot of 2's floating around in this thing. We can probably write this thing as 2 to some power here, both sides. So let's talk about this 64. 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. So this thing right here is 2 to the 6th, but it's 1 over 2 to the 6th. So this can be written as 2 to the minus 6th to the 3n times 8 equals 2 to the 6th. Right? Now, when you raise a power to a power, you multiply exponents. So this now can be written 2 to the minus 18n. And let's do this over on the right. Also, if we divide by 8, this is going to be 2 to the 6th over 8. And again, that's not 26, that's 2 to the 6th power. 8 is 2 to the 3rd. So this is 2 to the 6th over 2 to the 3rd, which is equal to 2 to the 3rd. So now we've got it in the form like 2 to the negative 18n equals 2 to the 3rd. So now these things must be equal. Minus 18n equals 3. So n is equal to, if we take 3 divided by negative 18, minus 1/6. I'm going to call that done. So sometimes equations with exponents can be solved without using logarithms. Your clue is, well, like right here, I can write this 64 as 2 to some power. And when you see things like that, you can work them this way. You can also do this by method of logarithms. We could have divided both sides by 8, taken the logarithm of both sides, and solved it that way. But I'm going to go ahead and move on here. Let's take a look at 16 here, where it says 7 times e to the 3n minus 5 plus 5 equals minus 89. So first we want to isolate this thing by subtracting 5 from both sides. So 7e to the 3n minus 5 is going to equal negative 94 by the time we take negative 89 and subtract 5. Then we're going to divide both sides by 7. So e to the 3n minus 5 is equal to, now that doesn't divide evenly. I'm going to go ahead and take a moment here and just do that division. See what I get right in decimal form. 94 divided by 7. 13.428. I'm just going to round that to 13.4 and call that good enough. Oh, and it's a negative number. So minus 13.4. All right, now what we want to do now is we've got to get the n out of the power, and that's what logarithms do for you. Now you can take either any base you want. Base e and base 10 are the two most common. You can take base 10 and it will work out just fine, but usually when you're dealing with e to a power, natural logs are probably the preferred choice. If for no other reason, ln is shorter to write than log, so if we take natural log e to the 3n minus 5, that's going to equal natural log of minus 13.4. So this is not defined, and I would say there's no solution to this thing. I'm going to take a moment here and just look it over, make sure I didn't make a mistake. Did I copy it down right? 7, 3n, negative 89. Yep, that looks right. I'm going to kind of investigate this. Okay, e to a power is always positive. You can't get a negative out of this. This thing's positive, this thing's positive. So there's, looking back on it, there's no way that this sum is equal to a negative number. So I'm going to say that my interpretation of this is correct. You can't take the natural log of a negative number. There's no solution to number 16. Let's take a look at 24. All right, we got 4 times e to the 3x plus 3 minus 7 equals 53. First thing we want to do is isolate this. So let's take this 4e to the 3x plus 3, add 7 to both sides. So that's going to be 53 plus 7, that's 60. Let's divide everything by 4, and we're going to have e to the 3x plus 3 equals 60 over 4. What is that, 15? All right, and again, here's where another problem where we need to get this out of the power. That's what the logarithm will do. You can take either base 10 or base e, but base e is shorter to write. ln e to the 3x plus 3 equals ln of 15. Now, by this beautiful property of logarithms, this can now be written 3x plus 2 times natural log of e equals natural log of 15. Here's where you get a little payback for using natural logs. Natural log of e is 1. So we can now write 3x plus 2 equals natural log of 15. Now, had we used log base 10, this term would not be a 1. It would be log base 10, and this would be log base 10. And you would divide that term out. So it would work fine with log base 10, but I'll go ahead and keep working with log base e. Subtract 2. Natural log 15 minus 2. Divide everything by 3, so x is going to equal natural log of 15 minus 2, everything over 3. Keep in mind this is not natural log of 15 minus 2. Like, it's natural log of 15, that number, minus 2. And then divide by 3. I'm going to go ahead and see if I can get a value for that. Natural log of 15 minus 2. For the top number, I get 0.708. Divide by 3. 0.236. I'm just going to round that to say approximately 0.24. Call that good enough. So the point of this video here is to help demonstrate how to solve equations that have unknowns in the exponents. I hope that that's done that for you. Have a great day.